Hi, my name is Jonas Coch. Richard showed us a couple of minutes ago how to be productive in Elm. I'm going to show you how my actual first complete Elm app, it's called Elm-search, the search engine that finds exposed functions of all published Elm packages by approximate type signature. I've developed it to learn the language itself, the tooling around it, and also some concepts of functional programming in general. So Elm is not only a fun language to program in, it also focuses on a nice developer experience that also manifests itself in how it handles packages. As the search works on published packages, I'll quickly show you how Elm packages look like, how they are published, and then how Elm-search is built upon this foundation that Elm offers. So when you write Elm code, you mainly declare new types or use existing ones, and you write functions that work on those types by accepting some arguments and returning a value. It might be a little hard to quickly see what this function here does, so you should add type annotation to clearly document the intent of the code. Elm also has special documentation comments. Those are important when you want to publish a package to the package catalog, as the tooling makes sure that all public functions are documented and type annotated. The same is also true for modules. Every function lives in a module. A module is just a Elm source file that contains types and functions that belong together by some logical meaning. One should explicitly expose types and values to define the module's public API. Modules are then bundled as a package. A package that gets declared in an Elm package.json file. Exposed modules need to be explicitly declared. So what happens to those packages? Packages are uploaded to the package catalog with the Elm package CLI. It makes sure that exposed functions and modules are properly documented and that the version number sticks to the semantic version in words. All the documentations and type annotations gets written into a documentation.json file, and the package catalog uses this JSON to build its documentation pages. Those look like this for the maybe module from the example, and specifically like this for the map function. The type annotation there contains links to the contained types, and the content of the documentation comments, they get transformed from Markdown into HTML. The documentation JSON it reads contains a list of all exposed types and values grouped by module. The name, type, annotation, and documentation comments of exposed functions are directly accessible as fields on an object. And this JSON is publicly available for each version of published packages. So how does Elm-search use the existing package infrastructure, and how does it work? It downloads all documentation JSON files of the latest published packages and creates one big combined index statically on each build. At the moment, there are around 15,000 exposed functions in the index. Then it passes the type annotation strings into a custom type to have some nicely structured data the search can work on. And it has a distance function that compares two type values by assigning a numeric value to the comparison. The type definition and the path are taken from the source code of the Elm package website. So I did not only get the documentation data basically for free, but also a great bit of code. A type can either be a function with a list of arguments and a return value, a type variable. This is a placeholder for some specific type, a type constructor, a tuple, or a record. The type is recursive, so tags can hold other types. And yeah, the type parser just takes an annotation string and returns a result. So the distance function now is basically the only thing I have to come up with on my own. It pattern matches on the two pass types and looks at interesting comparisons. In simple comparisons, it just calculates a numerical value. And when the pass type values are recursive, it calls itself recursively and then returns the mean of the different steps to get a normalized distance between 0 and 1. So interesting comparisons include functions. So the list comparison of the arguments, the order there is not important, and the comparison of the return values are handled separately. Interesting comparisons also include matching Elm's internal type classes to types implementing those classes. So for example, number to a float or an int, or matching types with special wrapped counterparts like a or maybe a or result a. So, and the list distance, this simplified version, the actual implementation checks if the lists have similar lengths and makes sure that the order of the lists are not important. It basically works by applying the distance function to each pair, summing the values up, and calculating the mean. So this is how the search looks like. The app initially loads a full index, pre-parses all the type annotations, keeping those in memory, and then parses the search input, compares each type with the existing type, and shows search result. that's basically it. Thank you.